All right, so let's begin right away. All right, let's say we have an equation. All right, so you're going to get your calculators out. I want to run through this. It's good practice anyway for your final. So let's get your calculators out. Red, let's do it. Come on, girl. Jad, let's go. Okay. Will. Yeah, go ahead. I don't care what you have to do. Just get them. Okay, we're going to do a funky one here. Okay. Lead, nitrate, and sodium iodide yields lead iodide, solid precipitate plus sodium nitrate aqueous. I'm not sure that's going to come up on the board, is it? Is it all there? Not quite. Let's back this up. Let's move it over a little bit, back it up, and we're cool. All right? Good? All right. We'll put in here aqueous, just so that you're used to equation writing. Okay? Equation writing, yeah. This is a little bit of a review, chapter 11. Okay? This is lead 2 nitrate. Why is it lead 2? Because you know nitrate's -1. Right? You're going to want to write the common polyatomic ions on your cheat sheet. Okay? I'm not going to put any funky ones there. Okay, yes, quickly, yes. You're going to have a real periodic table. Okay? Very, just name, symbol, mass, number, that's it. Okay. So it's aqueous means it's in solution. It's a question of surface area. You know, you got to be able to fit them together. Okay, is everybody paying attention to me or no? Are you? This is important. Okay, pick your battles, man. This is one that you should pick. Okay. This is lead, sodium iodide, +1, -1. So you're going to combine the ends, kind of like algebra, with the means and extremes, okay? And you're going to combine those two, and you'll form lead 2 iodide. You need a 2 there, and then sodium nitrate, +1 and -1, right? You're going to balance this. When the polyatomic ions are not split up, balance the polyatomic ions, don't balance the oxygen and the nitrogen separately. Okay? So I need 2 here. I need 2 iodides here. And sodium, 2 sodiums, 2 nitrates, 1 lead, 2 iodides, 2 iodides. Everything's cool. Yeah? Easy? Then the next thing you do right away, without even thinking, don't even think, just do it. Okay? Next thing you're going to do is this. You want to write the gram molecular masses, the molar masses. What's the mass of 1 mole of any substance is equal to or equivalent to the mass of 1 particle in atomic mass units. Okay? So let's do this. I'll be your periodic table. All right? So you have, what's lead? 207, right? 207. Is that right? Lead is 207. Yeah, 207. Just round. Just use mass numbers. Don't drive yourself out of your mind. Just use mass numbers. Okay? This isn't quantitative analysis in college. Just use mass numbers. So this is 207. That's 14. So that's 207, 14 twice, right? So 207 plus 28. And then that's 48, right? 3 times 16 times 2 is what? 96. So it's going to be 207 plus 28 plus 96, 330, 331. Is that right? What is that? Is that right? Can somebody add that? You know, yeah, that's why you have your calculator. You're like staring at me like I'm supposed to do all the work here. 207 plus 28 plus 96. It's going to be, what is it? 331? That's a little scary. Okay. All right. And then, what's that? 23, what's iodine? Shall I be your periodic table? 23 plus 127. Is that right? 23 plus 127, that's times 2 is 300. Is that right? Okay, because you have 2 moles, right? Double it. This is going to be 207 plus 254 plus 207 is what? 360 what? What is it? What is it? 361. Okay. 361, and that's going to be 23 plus 14 plus 48 is what? Times 2? What do you got? That's going to be 661 minus 361. What's it going to be? What? 290 something? What is it? Yes. Oh, 170? What am I doing wrong? No. 23 plus 14 plus 48. 85 times 2 is what? Are these equal? There's no way that's equal. What's going on? What's wrong? What's 23 plus 127 is what? What is it?
150.
That's right.
Yep.
Times 2, right? This is right? That's 127. Oh, no, this is wrong. This has got to be wrong. It's 127 times 2, right?
That's 254.
Plus 207. Right? It's 207 plus 127 plus 127 is what?
Which is 461.
461, okay? You see how I caught that? You see that? How did I do that? How did I catch it?
They have to be equal.
Yeah, conservation of mass. They've got to, the sides have to be equal. Otherwise, why bother? You see, a stoichiometric equation is simply a balanced formula equation. It's got to be balanced. Clear? Yes or no? Okay, it's got to be balanced. So now we have everything we have here. Okay, now let's do a problem. It's actually one problem in three or four parts. One problem, and I'll be able to teach all the concepts that you'll be responsible for on the test. Okay? And the math involved, 7th grade math. That's all it is. Concept involved, very basic. Clear? Yes or no? Okay. Do you understand the following? Red. That if I have 331 grams of this, I'm going to need 300 grams of this. Correct? Yes? And how much of this am I going to produce? I'll produce 461 plus 170. Could you just do a quick double check? 170 plus 461 is what? What is it? 631. Good. So it's always good to do a double check just in case. All right, just in case. All right, now. So let's say I have 1,000 grams of each. Okay? I want to know the following. A. I'll put it over here. Make sure we can see it on the film. I want to know limiting reagent. Right? Limiting reagent. I want to know excess reagent. I want to know amount of excess. Right? I want to know theoretical yield for the precipitate. See that line? It's a precipitate. Remember I did that chemical reaction and it turned yellow and orange and all, right? And, you know, that's the precipitate, right? That's the lead iodide, right? So I want to know how much of this, what mass. I want to know in other words, how much of this can I produce given these quantities, theoretically, based on the equation? I want to know the actual yield. I want to know the percent yield. Right? Clear? All right, so let's hustle. Okay? Yes? So, in order to do this, I've got to find out which one is going to be limiting and which one's going to be in excess. Okay? Right? I don't have everyone's attention. I mean, I'm seeing that you're like transfixed on your computer screen. It's obvious to me. I mean, you don't have to be an experienced teacher to know you're being ignored. Okay? So this is important. Okay? So don't sing the blues to me if you don't do well on your final, on your midterm, if you're not paying attention. I know who's not paying attention. This is important. Okay? Yes or no? It's one of the downsides of having your computer. Why don't you all shut your computers? Why do you have them open anyway? Just shut them. Okay? Yes? Okay? Now, so I'm gonna say, all right, I'm gonna compare these two. Clear? So in other words, I'm gonna say lead nitrate over sodium iodide, two of them. I'm going to compare though. That's a constant ratio. You see, the study of stoichiometry is simply studying those constant ratios. That ratio is constant always. You can bet your bippy, as they used to say in the 60s. So it's going to be 331 over 300. You can reduce that ratio. That's the ratio. It's constant. Constant. So all right, I say, all right, I'm going to use all of this and see how much of this I need. How much of this do I need to combine with 1,000? So I'm going to say 1,000 over x. Give me a reading. Come on, take out your calculators. Come on, guys, let's do it. 300 times 1,000 divided by 331. Everybody, take out your calculator. I don't care if you're using a phone. Doesn't bother me as long as it's not a test. Mohammed, you have a phone?
300.
Yeah, you have a phone, right? We'll take it out and get out a simple calculator. Remember, 7th grade math. You don't need a scientific calculator. Yes, sir.
906.34.
906. Just give me ones place. Look, guys, when you're doing stoichiometry in moles, especially for the first time, as long as it's not quantitative, use mass numbers and round to ones place. Don't drive yourself out of your mind.
906.
906?
Yes.
All right, so I need 906, right? So x equals 906. So I'm going to get 906. Sorry. So I'm going to need 906 over here. So what's going to be limiting and what's one's going to be in excess? Don't know yet? All right, let's do another one. So then let's say instead, we're going to rewrite that, and then we're going to say 331 over 300 equals x over 1,000. So let's say I burn all of this. How much of this do I need? Okay, so do that. 331 times 1,000 divided by 300. What do you got? 1,103. 1103. Okay, so you need 1103 grams of that. Do I have 1103? No. So do you get it yet? I want you to figure this out. What's limiting the reactions? If you have 1,000 of each, which one is going to limit how much product you get eventually? Which one? If I use all of this, I only need 906 of this, right? Can that work? If I use all this, do I have 906?
Yes.
So can that work?
Yes.
Okay, good. If I use all of this, I need 1103. Do I have 1103?
No.
That's not going to work. So what's limiting the reaction? What's limiting the product? lead 2 nitrate. That's limiting it, right? Right? Yes or no?
Yes.
Yeah. Well, you can put any masses you want here. I could say, well, let's say there's 1,432, and over here there's 1,203. Which one's limiting? I mean, you can put down whatever you want, but the idea is that you've got to do the comparison. You got to see if you have enough of each. You see that? Just a very quick, is this or is this not middle school math? Yeah. Is it or not just simply proportional relationships, isn't it? I say this. I say 331 is to 300 as 1,000 is to what? I say 331 is to 300 as this 1,000 is to what? That's proportional relationships. What could be more natural? When do you learn proportional relationships? 3rd grade, 2nd grade, 4th grade, right? You're just comparing two things, that's all, right? Yes? If I say to you, 6 over 12 equals x over 4.
2.
So 6 is to 12 as what is to 4?
2.
2, right? Right? Isn't that a proportional relationship? Yes or no? Okay. Now, so how much of this now, can I erase some of this stuff now? Okay? All right. So 906, okay, good. Now, so what's going to be the limiting reagent? This one, right?
Yes.
All right, now, so let's compare these two. So lead, nitrate is to lead iodide, right? Right? As 331 is to 461, right? Yes? So I have 1,000. Obviously, what's the answer going to be? It's going to be a little bit more than 1,000, isn't it? The answer, right? Yes? So 331 is less than, right? Yes? So give me the reading. What is 461 times 1,000 divided by 331? Red? 1392. So this is going to be 1392. X equals 1392. Right? So this is 1392. Right? Grams, right? Yes? Yes or no? All right, now. So we know what the limiting reagent is going to be. We know how much is left over. How much is left over? This is limiting reagent. This is excess reagent, right? How much is left over? 94 grams, right? It's going to be 94 grams hanging out, right? Yes or no? But it's going to be dissolved, right? I don't have to worry about it. I can just decant it and wash it. It's going to be the dissolved material will just go right through the filter paper, right? And I'll be left with the precipitate, right? So I can just wash it. So I can make it pretty pure. Yes? Okay. Now, what's the theoretical yield? 1392, right? That's the theoretical yield. That's how much I can get. You get that, Neve? Makes sense, right? That's how much I can get, theoretically. What does the equation predict? That's all this is. That's all chemistry is. Using the organization of the atom in order to predict things, to predict stuff. Okay, Ms. Swain, are you being bothered back there? Excellent, excellent, excellent. Alec, you are encouraging her, is that correct? I like that, I like that. You're being a coach. Okay, you're using your skills as a basketball player in order to coach your partner into fulfilling her complete potential in chemistry. Is that correct? Excellent. Well done. All right, now, so let's say you're a complete and utter slob, right? Slob, and you only get 1,000. grams of that. Exactly 1,000, man. We're talking 1,000. That's all you get. You're a slob, okay? Now, we know what the theoretical yield is. It's 1392. I gave you the actual yield. You'd actually measure that in the laboratory. You'd actually measure that. Yes? Now, what's the percent yield? In other words, given 1,000 grams of this reactant, given 1,000 grams of that reactant, where you could theoretically get 1,392 grams and you only get 1,000 grams, what is the actual percent yield that you got in the reaction? What's the percent yield? Well, how would you get that? What makes sense to you? What is it? Well, maybe. Just in terms of 100. What would you divide and then multiply by 100? I like that. That sounds about right. How did you get that?
1,000 divided by 1,000.
Yeah, 1,000 divided by 1392 times 100, right? In other words, okay, right here, the percent yield equals, right, the actual over the theoretical times 100, right? Yes? So it's going to be 1,000 divided by 1392 times 100. And what did you get?
79%. Also 86.
Remember, don't drive yourself crazy with this stuff. Yes? Remember, you're young, elementary chemistry students. Don't go crazy. Use mass numbers. I don't care what the book says. I don't care what another teacher says. They're full of baloney. They're full of poop. Okay? They are. It's nonsensical. Use mass numbers and round to ones place. If you need to round to tenths place or hundredths place, I will tell you that. Like when you do empirical formulas, which we really didn't do a lot of, but I think I did some problems, and there are also videos. Don't forget there's videos that you can look up from last year, as well as the ones I did for this year, that you can look up empirical formula. You're going to round to, you're going to put it into thousandths place. You want everything in thousandths place. Am I all done? What's wrong with the video?
No, it's still recording. It just says low
It says low battery. It's the battery on this is not doing well. It was fully charged when I started. All right, so the battery's gonna die, so I'm gonna have to finish this up within the next 30 seconds. Now this is important. How many people, when you study, you know what you know, and you really know what you don't know? And oftentimes students make the following mistake. They'll read a chapter, and even though they know it, they'll reread it because they feel compelled to do that. Have you ever done that?
Yes.
And but it's a waste of time because you already know that. Don't you know what you're uncomfortable with? Of course you do. You're reading it, you're like, what the heck? What does that mean? And so what's the human nature? The human nature is to read something you know because you feel better about yourself, right? Right? Well, know what you know and don't do that. Know what you don't know and look up a video from last year or this year, whatever, and look it over. Clear? So don't go crazy. Don't go crazy. I would rather you take Sunday night off from studying. Rent Uncle Buck. My niece used to call me Uncle Buck. Anybody ever seen Uncle Buck?
No, sir.
That's me. That was me, although I wasn't as big as John Candy, but...
Is he supposed to be a really fat man?
Well, no, the fact that he's heavy is not part of the plot.
Oh.
But it's a great movie. It's funny. It's very funny. It's great for teenagers. You don't want to watch it if you're younger than a teenager, but it's pretty funny.
Does it have Macaulay Culkin?
Yeah, the guy from Home Alone. He did that movie, I think, before Home Alone. It's a great movie. It's kind of funny. I mean, it's pretty cool. It's good. It's got everything in it. It's got everything: comedy, drama, melodrama.
Sounds like a plan.
Yeah.
What's
I like that.
All right, so get a good sleep, but study between now and then. You can pick your battles, can't you? Neve, can't you know how to pick your battles, right? You know when to give me a hard time and to annoy me. You pick battles, right? You push my buttons when you want to, and you don't when you don't want to, right? You pick battles. I pick battles. Don't you pick battles, Mr. Excitement? Okay, right? Yes. Red, don't you pick battles? Well, you don't fight with anybody. You're like too nice. Okay, I'm giving you no extra credit because you're too nice. Okay, I'm charging you excess nice tax. Okay, okay. Gabby is actually rotten. She just pretends to be nice. Okay, all right.
Rick has you all confused over there.
Oh yeah, well yeah. Okay, the jealousy is coming through. That doesn't surprise me. What did I just say? Yeah, you're right. You're absolutely right. Okay, okay. And Will just likes to watch everybody fight, okay? So anyway, hey, listen, have a great day. Have a great tomorrow. Be safe. I won't see you unless you want to come in and hang out. I have no classes tomorrow, so if you want to, ask me questions, you can. See you later, guys.